So we'll have a quick revision of these problems because according to me, PDA, if you understand and solve it correctly, you'll get very good marks and there are very less chances of making mistakes. So L is equal to AB raised to N, CD raised to N. This was one of the problems that we have studied where N is greater than or equal to 1. So what is the logic for it? For each AB, we push X onto the stack. For each CD, we will pop X out of the stack. So we start with Q0 state. So we take 4 different states, Q0, Q1, Q2, and Q3. Q0 input is A, stack top is R. We don't perform any operation because it is for AB combined. So we keep R as it is, just change the state to Q1 because B will be followed after A. Then in Q1, when we get B, stack top is R, we go to Q0 and push X onto the stack. Then again in Q0, if we get A and stack top is X, we keep stack top as it is, just change the state. So we go to Q1. In Q1, when we get B, stack top is X, we change the state to Q0 and push X onto the stack. So the first two operations that are there, they happen just once. If more AB comes in, then these operations will get repeated. We are in Q0 and if C comes in, so we change the state. So there is Q2 related to C. We go to Q2. We do not perform any operation because pop operation will be on combined CD. So we are waiting for D. So in Q2, when we get D, we change the state and then we pop the stack top element. Now we are in Q3, C comes in, we go to Q2 and X is kept as it is. Now we are not writing again Q2 when we get dx. Why? Because this will get repeated. So these two statements get repeated, only this one statement happens once whenever we are solving problems. So Q2, Q3, Q3, Q2, this change of states will happen for CD. And here Q0, Q1, Q1, Q0, this will happen for AB. So in Q3, when we get epsilon and stack top is R, we go to the final state QF and R is kept as it is. So we are taking an example and solving it. Q0, AB, AB, CD, CD. So this, you can make out that 2x will be pushed onto the stack and 2x will be popped out of the stack. Let us check whether the transitions are doing the same thing, whatever we have written here. Q0, when we get A, we change the state to Q1. Q1, when we get B, we change the state to Q0 and push X here. Then Q0, when we get A, we go to Q1, and Q1, when we get B, we go to Q0 and push another X onto the stack. So it comes here. Then Q0, when we get C, we change the state to Q2 and do not perform any operations onto the stack. Whenever in Q2, when we get D, we go to Q3 and then we pop the stack top element. Q3, when we get C, we go to Q2 and Q2, when we get D, we pop the stack top element. In Q3, we come to the end of the input and stack top is R, then we go to QF. That is the final state. So these type of questions are important. So you need to practice it properly so that you are able to solve it. You may know the logic, just this change of state is also very important. And when to push X onto the stack and when to pop X, you have to take care while solving this problem. Then one more problem we had seen, L is equal to 0 raised to N, 1 raised to M, 2 raised to N. So solve this problem on your own. This, I think so you have done. You had solved this problem on your own. So for each 0 we push X, we bypass all the ones, and for each 2 that we get, we pop X out of the stack. So that is the logic for this particular problem. Then we had seen L is equal to A raised to N, B raised to M, C raised to M, D raised to N. So we have to match the number of A's with the number of D's and number of B's with the number of C's. So we use two different elements to be pushed onto the stack, pushed and popped. So for each A we push X, for each D we pop X, for each B we push Y, and for each C we pop Y. And four different states for these states, Q0, Q1, Q2 and Q3. So initially stack top is R, Q0 when we get A, we push X onto the stack and state remains the same. Q0 when we get A, stack top is X, we push another X onto the stack. Then Q0 when we get B, stack top is X, we push Y onto the stack and change the state to Q1. And Q1 we get B, stack top is Y, we stay in the same state Q1 and push Y onto the stack because we have decided that logic here. Q1 when we get C, stack top is Y, we go to Q2. First the change of state and then we pop the stack top element. So in this case Y will be popped out. Q2 when we get C, stack top is Y, we stay in the same state Q2 and pop the stack top element out of the stack. Q2 when we get D, stack top is X, we change the state first, so we go to Q3 and remove the stack top element which will be X. Q3 stack top is D, input is D, stack top is X. We we stay in the same state Q3 and remove the stack top element. Q3 when the input is finished, stack top is R, we go to the final state QF. And you can take one problem for practice, AA, B, C, D, D. So like that you can take one problem and solve it. Then this was the last problem, X where number of A's in X is equal to number of B's. In this type of problems, when the order is not given, we don't change the state. In the previous problems, what we have seen till now, we were changing the state. Because the order was fixed. First you will have all the A's, then you will have all the B's, then you'll have all the C's, then you'll have all the D's. Here you'll have all zeros first, which could be one or more, ones followed by ones, which could be one or more, followed by twos, which could be one or more. So here, to understand that A's are coming first or B's are coming first, we use a different logic. Suppose A comes in, we push X onto the stack. If B comes in after that, we pop X out of the stack. Suppose B comes in first, we push Y onto the stack. And suppose A comes in after that, we pop that Y. So that is that particular logic that we are going to use in this problem. We don't change the state because the order is not known to us. So in Q0, A comes in, stack top is R. So we have decided we'll push X onto the stack. And suppose we are in Q0, B comes in and stack top is R. That time we push Y onto the stack. Now in Q0, A comes in and we have stack top as X. This indicates that earlier there was A. Stack top as X indicate that earlier A had come. So we push X onto the stack. In Q0, A comes in and stack top is Y, which means earlier B had come. So we need to pop that element. So we pop the stack top element. In Q0, B comes in, stack top is X, which indicates that earlier A had come. So we pop the stack top element. Q0, B comes in, stack top is Y. We stay in the same state Q0 and we push Y onto the stack. And then Q0 input is ended, stack top is R. That means whatever values you have pushed onto the stack or variables you have pushed onto the stack, you have removed. So we go to the final state and R stays as it is. So Q0, so there are four different examples which you have practiced, AA, BB, BB, AA, A, B, B, A, B, A, A, B. Now Q0, when we get A, we push X onto the stack. Another A, we will push X. B will pop X. Another B will pop X out of the stack. Next example, we'll push Y 2 times onto the stack and then we'll remove Y out of the stack. Next example, A, B, B, A, we push X and then remove that X. We push Y and then remove that Y. Here we push Y first and remove that Y, then push X and remove that X. So push down automata is not very complicated and it is likely that you'll make lesser mistakes here, so practice it more. So next question, L is equal to B, C, D, A whole raised to N, E raised to N, where N is greater than or equal to 1. Have you solved it, Pratik? Have you solved this problem?
Yes, sir.
You can just paste it.
I have not solved the example yet. I
Fine, fine.
solved the.
You can just paste the transition functions first, then you solve an example.
Okay.
So here also we are using different states for different inputs because the order is fixed. B, C, D, A. That is the order that we have to follow. So we'll just change the state from 0 to 1 on getting B, 1 to 2 on getting C, 2 to 3 on getting D, and 3 to 0 on getting A. And then you push X onto the stack. Because for each B, C, D, A, we are going to push. When we get that B, C, D, A combined, then only we'll push X onto the stack. This is when the stack top is R. And suppose the stack top is X. So Q0 to Q1 on getting B, Q1 to Q2 on getting C, Q2 to Q3 on getting D, and Q3 to Q0 on getting A. And then you push X onto the stack. So we'll be in Q0 and E comes in. So we change the state to Q4, stack top is X, and we remove the stack top element. In Q4, another E comes in, stack top is X, then we remove the stack top element out of the stack. In Q4, input ends and stack top is R, then we go to QF. Are you getting this? So this is how you'll draw the transition diagram. Input is Input is B, stack top is R, you keep R as it is. Input is C, stack top is R, you keep R as it is. Input is D, stack top is R, you keep R as it is. Input is A, stack top is R, you push X onto the stack, so it becomes XR. Similarly, P, stack top is X, you keep X as it is. C, D, just change of state happens, and in the last, when you get A, you push X onto the stack. From Q0, if you get E, directly we go to Q4. And Q4, if more E's come in, then we remove the stack top element. After the input ends, stack top is R, we keep R as it is, go to the final state. Is it clear? Now next problem is design push down automata to check well formedness of parentheses. Can anyone tell me what do you mean by well formedness? Yes. Well formedness of parenthesis. So parenthesis is this. Well formedness means for each opening parenthesis there is a closing parenthesis. So opening, closing. But it could also be two openings, one closing, one opening, one closing, and closing. So this is also coming under well formedness of parenthesis, because for three opening there are three closing brackets. We could also have this and this. This is also a well formed example. So we need to accept all such type of examples. Can anyone tell me what logic can you use here? Yes.
For every opening bracket we push X, and for every closing bracket we pop it.
Only X is required. Y also is required here. Yes, Pratik, Y is required here.
I don't think so. X should be enough for like for opening bracket X, then equivalent closing bracket should remove that X. If it is equal, then we will have empty stack.
Yes, X is enough here. No need to have any other variable. So this is in stack top is R. In Q0, we get opening bracket or opening parenthesis. Stack top is R. We push X onto the stack. In Q0, another opening bracket comes in. Stack top is X. We'll push X onto the stack. Here, we don't change the state because the order is not fixed. On getting a closing parenthesis, we pop the stack top element out of the stack. So we have just written 4 transitions. Any more transitions are required?
No, sir.
Just take the above example and solve it. 2 opening brackets, 1 closing, 2 opening, 1 closing, 1 opening, 2 closing, and 1 more closing. So Q0, when we get opening bracket, we'll push X onto the stack. Another opening bracket. Then a closing bracket will pop X out of the stack. So we'll have one X only. Then we have 2 opening bracket. Another closing bracket comes in, so we remove X out of the stack. There's just a mistake here. This thing is not there. Suppose we put one more closing bracket, so we'll see what happens.
All of you fill the attendance.
Yes, everyone, please fill your attendance. Sir has posted in the chat section. Now we are in Q0. We have one more closing bracket and stack top is R. So there is no transition for this. So we'll get stuck here. We cannot go to final state. Are you getting? So if it is unequal or well formedness is not there, then you will get stuck somewhere in between and you cannot go to the final state. Everyone, please give your attendance first. So there is a language given L is equal to WCW raised to R. So what do you mean by this? W consists of A's and B's. And after C, there is a WR, which stands for reverse of W. So we can take an example. A, B, B, A, A. C. So after this, there is a reverse of this. So we'll have two A's first, followed by two B's, followed by A. So this is your word, this is the C, and this is your reverse of that particular word. So word is formed out of A's and B's. Now the logic in this that we'll be using is whenever A comes in, we push X onto the stack. If B comes in, we push Y onto the stack. Are you getting? Till the time we reach C. So A comes in, we use a variable X, we keep on pushing X onto the stack. If B comes in, we keep on pushing Y onto the stack till C comes in. Once C comes in, then we will change the state, and after that A's and B's come in, then we can pop the element out of the stack. Just remember that we are using a variable X for A, Y for B. This we have already learned. So in similar way, we are going to start till we get C. So we are in Q0, A comes in, stack top is R, and we are in Q0. If B comes in, stack top is R. So we'll write transitions for this. We'll stay in the same state, but remember, we have to push X whenever we get A as the input, and we have to push Y whenever we get B as the input. This is till we reach C, which is dividing the word and its reverse. Now suppose we are having A as the input, stack top is X. We can also be in Q0, have A as the input and stack top is Y. This is possible. We are in Q0. Input is B, stack top can be X. We are in Q0, input is B, stack top can be Y. So what do? We push X onto the stack whenever we get A. So already there was stack top X, so you push X on X. If the stack top was Y, we push X on Y. So, so we follow this particular logic. Then for B, we have decided we'll push Y. So we push Y on X. In Q0, we push Y on Y when the stack top is Y. So this is the logic that we follow till we reach C. Has everyone understood this? Now we are in Q0. We get a C, and suppose we get X. Stack top is X. We are supposed to just change the state and keep the stack top as it is. But we can have Y also as the stack top when we get C. So that is also possible. So we'll have to write one more transition in Q0. We get the input as C, stack top is Y. Just change the state, keep the stack top as it is. And in this question, they have not given the number of A's and B's. There is no limit. We are in Q0. There is no input. No input of A's and B's, and directly C comes in and stack top is R. We just change the state to Q1 and keep R as it is. So this is also possible because here there is no restriction on the length of the string. So there is nothing on this W part. Only C is present. So that time also reverse will be blank only. So that time we get C, stack top is R. We change the state and keep R as it is. Are you getting this? Now, just pay attention on the example. We are having a word and its reverse. So if you see, for A we will be pushing X onto the stack, for B we'll be pushing Y onto the stack. First A we have pushed X, then we got 2B, so we have pushed 2Ys onto the stack. Then we have got 2A, so we have pushed 2X onto the stack. So if you observe, when this A comes in, we'll have X onto the stack. This A comes in, we'll have X onto the stack. When this B comes in, we'll have Y. When this B comes in, we have Y. When A comes in, we have X onto the stack. So we have to just write transitions for these. When A comes in, we are in Q1 now. And A comes in, stack top will be X. Then only you pop the element out of the stack. Are you getting? Q1, when we get B as the input, stack top will be Y always. Then only it is valid. So that time only we'll pop the element out of the stack. Stack top element out of the stack. Is it clear? So for push operations, we have to write a lot of transitions. But for pop operation, we need only 2 transitions. For changing also, we need only 3 transitions. But here we need 6 transitions for push operations. Are you getting this? Now after this, if the input ends and we are in Q1, stack top has to be R. Then only we'll go to the final state QF. Are you getting this?
Sir, there will also be transition for state Q1 and we get input C.
What happened?
Sir, there should also be transition for state Q1 and we get input C. It should stay in Q1 and like that.
So this C here is just used as a separator. It is only going to occur just once. Getting? It is not raised to something.
Yes.
So just we'll use these 3 transitions down here for change of state. So this C, what it does, it is acts as a separator between the word and its reverse. So we come to know that after C, we have to just pop the elements out and we'll be able to match the word which was present earlier to its reverse. Are you getting this? Here it is not
Yes, sir.
raised to something. This C is used as a separator. Suppose this C is not there, then you will not understand when is the reverse starting. Yes?
Yes.
So it will become difficult for you to perform the pop operations. Have you all understood this? So this type of problems can also come in which they give you a generalized form in which you need to solve that particular problem. So this is generalized form. We don't know the words here. It could start with A, it could start with B. And we need to match the word which is on the left to the word to the, and the reverse will be present on the right. So that can be done using this particular method, where you push X onto the stack for each A, for each B, you'll push Y onto the stack till the time you get a C. And after that, when you get A, you pop X out of the stack. And when you get B, you pop Y out of the stack. And once the input is has ended, once the input has ended and you are in Q1, stack top is R, then you go to the final state. Hope so it is clear to all of you. This is quite a good problem which can be asked So you need to understand it properly,